Good morning, everyone. So today we're going to take a look at magnets. So we're going to do a few different experiments and just see how magnets work. All right, let's get started. Imagine people's surprise when they came across the first magnet. It must have seemed like a magic stone to them, able to make tiny pieces of iron rise up and slide around by some invisible force. The earliest record of magnets are from the Chinese and the Greeks, who both wrote about lodestones, which are naturally occurring stones that attract iron. Today we know that lodestones contain magnetite, a naturally occurring magnetic material. Through experimentation and observation, both the Chinese and the Greeks eventually began to use these magnetic lodestones to make compasses to use for navigation at sea. But it took until the 1600s before major scientific understanding of magnets occurred, and scientists are still discovering more and more about magnetic principles today. One of the most basic and important features of the magnets is that when allowed to rotate freely on a piece of string, they always align themselves so that one end faces the North Pole and the other end faces the South Pole. These two ends are referred to as the North Pole and the South Pole. By aligning the poles of two magnets in different combinations, the magnets will either be attracted, so pulled closer to one another, or repelled, pushed further apart from one another. All right, so we're going to learn a little bit more about magnets. So first we're going to put the two poles together. So we're going to put North Pole and North Pole, so the red and the red together. We're going to see if they push or pull away from each other. So it's pushing it away and turning it. All right, and then we're going to do north and south, and we're going to see what happens. So it's been attracted. And then we're going to do south and south, and we're going to move them, and we're going to see what happens. So it moves away. So it's repelled. The next experiment we're going to do is called the levitating ring experiment. So we're going to take advantage of them repelling each other to make it float. So first I'm going to put my first ring on. It doesn't want to go down, look at. So there's a magnet in the bottom of the base. So as I push it down, it does not want to go near the base. But if I turn it over so that the red side's there, it's attracted. So it looks like magic, but it's a magnetic field that is repelling because they're both the same. So they're both south pole sides of a magnet. So they're repelling. But then if I change it, they are attracted to one another because they are opposites. All right, so now I'm going to do a magic trick using magnetic principles, where I'm going to do the North Pole touching the North Pole. They float. And then I'm going to change it, and then we're going to have the blue touch the blue. So they're all floating. But if I change it around, so if we're doing a repel, and then we have attract, and then we have repel. So that is our levitating magnet. Magnets are fun to play with. All right. The next one we're going to do is we're going to look at magnetic fields. So I need a white piece of paper, and I'm going to put two bar magnets underneath. Or I'm going to first do where they're the opposite. So we're going to have a south pole and a north pole, and we know that this attracts. As you can see, they attract, but I'm going to make them about an inch apart so they don't touch, but then we can look at their magnetic field when I put a paper over top. And then I'm going to take iron filings and I'm going to put them on top. So I'm going to sprinkle them on top so you can see the magnetic field, so what it's doing. So iron filings are attracted to the magnet, and it allows you to see the magnetic field around the magnet. So I've moved you down closer so you can see the pattern of the iron filings. So if you look, it's moving out because it's repelled, because it's all the same end. And then if you look in the middle, see how it's moving from, there's like a little swirl that goes between these two. So the field is attracted to one another. So this field is moving away because it's the same, so it's repelled. But then because you kind of in the center here, you have the north and the south pole. You then have iron filings curving, and they're attracted to one another. And then over here, you also have it curving because it's attracted. And if you look in the center, you can really see there's a magnetic field because it's attracted to one another, so it wants to move together. And then you have the same over here where it's kind of moving out because it's the similar. And then in the center, it's attracted to one another because it's the field in between. It's right in the middle between the north and the south pole, so it's made a nice curve. And then here, it's kind of moving out. So this is what the field looks like when you have a side where it's attracted. So I'm going to change them around. So we have both ends. Look at when you move it, it does not want to go anywhere near it. So we're going to bring it as close as possible before it turns. And then I'm going to put the paper on top. And we're going to shake our iron filings on top. I'm just reusing the paper, but you'll get a good picture. So with the iron filings on and the magnets repelling, if you notice in the center, the magnetic field is not there. You notice it's repelling away. So there's nothing in the center, whereas attracting, you had lines moving from one end of the magnet to the other. So if you look, see the swirls really there? So it's repelling out. So in here you can see where it's attracted because it's in the middle from the north and south pole. So it's really attracted to one another and making swirls that are going from one to the other. And then at the ends, it's moving out because it's not attracted to itself on the ends. So it's repelling. So in here it's attracted, and there it's repelling. Magnets come in many shapes and sizes. So if you look around your house, do you see a magnet? Magnets make objects move. Magnets attract metals such as steel, iron, and nickel. If you put a paper clip close to a magnet, watch it jump and stick to the magnet. Magnets cannot make all metal move. A magnet will not stick to this soda can. So paper, wood, and plastic objects are not magnetic. Opposite poles attract and pull together. The north and south pole attract. Attract means to pull something close. The same poles repel and push away from each other. If you try to touch the north poles together, they will jump apart. All around the magnet is an invisible area called a magnetic field. The magnetic field attracts magnetic objects. Magnets help people do work. Magnets are inside of many things, like MRI machines, computers, and microwaves. Electric magnets are used in many electric devices. A compass is a magnet that helps people find their way. The magnets on the board help hold up paper. Magnets are everywhere. Magnets are used in a wide variety of household objects, including headphones, televisions, computer disks, and refrigerator magnets. Recently, engineers have used magnets to create maglev, which is short for magnetic levitation trains, which is this. So these maglev trains use attractive and repellent nature of magnets to levitate or float above the tracks rather than use wheels. The first commercial high-speed maglev train, located in Shanghai, China, began transporting people in December of 2003. It averages 250 miles per hour. So I hope you guys enjoyed learning a little bit about magnets today, and we'll see you next week. Bye, guys!